So now let's look at how different conic sections are formed. Now this would require a lot of 3D visualization from your side. Let us assume I was to take two hollow cones and I was to put them one straight and the other in the upside down format, exactly like this. And if I were to take up a plane and try to slice this entire structure at different angles at different planes, then the part of the conic that has been cut would represent different shapes that have been formed, and those shapes are nothing but our parabola, ellipse, hyperbola and circle. So first let me show you how these different shapes look like. For example, parabola. If I were to draw the graph or the shape of parabola, it looks somewhat like this. We have already studied about parabolas in quadratic equations as well. And if I were to talk about circle, again, everybody knows how a circle looks like. And we have also studied a lot about this in the previous lecture series. Ellipse. This might be a fairly new thing for you all. Ellipse is nothing but a advanced form of a circle where there is a center and there are two different axes here. One is the short one and the other is the long one. We call this the major axis and the short one the minor axis. And then there is another shape which is known as hyperbola, which somewhat looks like this. Let's say if this was our graphical scale, x and y axis, then a hyperbola would look like this. Now you might be asking that hyperbola is basically nothing but a combination of two parabolas. No, it is not that. The equation of this part and this part comes together. That is why it is completely different from a parabola. So that is how these shapes look like. Now let us say if I was to take a plane and if I was to slice this cones at different angles at different positions, then I would simply get these structures. For example, if I slice it from here, then the shape formed here would be a circle. And if I take this plane again and I slice it from here, then the shape that would be formed here would be in this format, which would look like a parabola. I'll draw it once again so that it becomes clear for you to understand ellipse and hyperbola as well. If I were to take a plane and slice it from here, then there would be two shapes formed. One would be here and the other would be here. Exactly how a hyperbola is formed. That two curves separated by certain distance. And if I was to slice from the middle at a slanted angle, then the shape formed here would be that of an ellipse. This would be an ellipse and this would be a hyperbola. So that is how different conic sections are formed. I have a 3D image to show you this entire thing even more clearly. Here you can see this is a plane that has been used to slice this conical structure here. Now again, to remember one thing that you need to remember, this is a hollow cone and not a solid cone, because had it been a solid cone, then we wouldn't have gotten one line or one curvature which would define the different sections. That is why we used a hollow cone to find out this. If I slice it at an angle which exits from one side and is solid from the other, then we would get a parabola as shown here. If I were to slice it horizontally, we would get a circle. If we were to slice it at an angle, we would get ellipse, and hyperbola is again a vertical slice in between. So this is how different conic sections are formed. Now let's look at the general equation as to how all these conic sections can be represented. As it has been written here, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Now this general equation not only justifies our different conic sections formula, but also justifies a straight line formula as well. Now if let's say in this equation, we have previously looked at this equation at straight line. Let's say if I were to say a is equal to 0, h is equal to 0 and b is also equal to 0, then what would this indicate? That there are only x and y terms and there is a constant term. So this would indicate this is an equation of a straight line. And let's say if I was to transform this into a circle's equation, then I would say a is equal to b and h is equal to 0. Thus this would transform into a circle's equation. You can put these formulas and see. If a is equal to b, that means the coefficient of x and y, x square and y square are same, and there is no xy term. And this is exactly what we had studied in circles. So this can be formed from here. Now from this equation, how can we get the equation of parabolas, hyperbola and ellipse? That is a thing that we will study now. And also how differently we can represent this equation. So here, to find out the equation of different conics, the major thing that we need to find out is the determinant of this equation. For this equation, to find equation of other conics, we calculate the determinant. And we have studied in matrices and determinant as to how we can calculate determinants. And the way we represent the determinant is A, B and C, which are in the major principal row, or we can say principal cross row of the determinant. And we write H here, G is at the corner, and then F here. So the determinant of this, somehow if we calculate it, it turns out to be this. Now based on the value of this determinant, we classify whether it is a parabola, ellipse or hyperbola. So we'll see that in the next slide here. Now let's say if delta is equal to 0. Here the equation of delta was ABC plus 2FGH minus AF square minus BG square minus CH square. Now let's say if this thing equates to 0, then what are the things that we can tell from there, or what are the conditions through which we can tell what type of conic that is? And along with delta is equal to 0, AB minus H square is also equal to 0, where I hope you remember A and B are coefficients of x square and y square, and H is the coefficient of xy. So if AB minus H square is equal to 0, then we can say that it is a pair of coincident straight lines. And we very well know what coincident straight lines are. We had studied this in straight lines lecture series. And if AB minus H square is less than 0, that means AB is less than H square, then it would be a pair of intersecting straight lines. And if AB minus H square is greater than 0, then we know it is going to be a simple point. That means that equation would equate to a point. It signifies a point. It does not signify any type of conic, whether it is a straight line, circle. It is just a point. So again, this table is very important and you need to remember this, because sometimes JEE asks questions based on this thing. Now another thing, if delta is not equal to 0, our second case, then what are the things that we can conclude from here? If delta is not equal to 0, H is equal to 0 and E equals to B, this I had told you in the first slide, it will equate to a circle. If AB is equal to H square, then it is a parabola, which looks like this. If AB is greater than H square, then it equates to an ellipse. If AB is less than H square, then it equates to a hyperbola. And if AB is less than H square and A plus B is also equal to 0, it becomes a rectangular hyperbola. I'll just show you how a rectangular hyperbola looks like. It is also a part of hyperbola, which we will be studying in detail when we study the chapter hyperbola. This is how a rectangular hyperbola looks like. So for the time being, you just need to remember how this looks and what is the condition through which we can say that this is a rectangular hyperbola. Now this again is a very lengthy method to justify what type of conic we have. We have to find out first the delta, which is the determinant, and then from the determinant we have to check whether it is 0 or non-zero, and then calculate a few other conditions. Then we will be able to say whether this conic is a circle, parabola, ellipse, or etc. There is a shortcut trick also to find out what type of conic it is. So now again, let's look at the shortcut method through which you can calculate or find out what type of conic section it is. I hope you all remember from the chapter quadratic equations we used to find out discriminant. Which used to be b square minus 4ac. So same thing we will do here. So we know what our general equation is, plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. Let us represent this entire general equation in a different form so that we can eliminate all these constant terms from here, and we have only variables in front of, we have only constants, single constant in front of the variables. So let's write this equation down as a x square plus b xy plus c y square plus d x plus e y plus f is equal to 0. Here we all know f is equal to c, e is equal to 2f, d is equal to 2g, c is equal to b, b is equal to 2h, and capital A is equal to small a. Now once we've represented our general equation in this format, then we can simply find out b square minus 4ac. And once we found out this, then based on the value of this, whether it is negative, positive, or 0, we can say whether our conic or the equation that has been given to us is an ellipse, hyperbola, or a parabola. So let us look at those conditions now. So the exact thing has been given here. We've represented our general equation in this format, and then we've taken out our discriminant, which is b square minus 4ac. And if it is less than 0, then it is an ellipse. Or if b square minus 4ac is less than 0 and a is equal to c and b is equal to 0, then we can say that this is the equation of a circle. I hope you all can understand b needs to be 0 because it is the coefficient of xy, and a needs to be equal to c, and if that is the case, we will get this to be a circle. And if that is not the case, let's say a equal to c and b equal to 0, these two conditions are not being satisfied at the same time. However, b square minus 4ac is less than 0, this is satisfied, then it becomes an ellipse. And if it is equal to 0, it becomes a parabola, greater than 0, it becomes a hyperbola. So this is a shortcut method to find out what type of conic we are dealing with. What does the conic, the general equation, refers to. So now let's do an example. Now just to remind you, whenever there are any questions that comes up during our lecture series, or whenever there is an example that I give you to solve, I would request all of you to first pause the video, try to solve the question by yourself, and then look at the solution of the equation. This would help you learn and see whether you've understood the concepts of the chapter or not. So let me take an example here. Let's say the general equation given to us is x square plus 4xy plus y square minus 7x plus 8y minus 24 equal to 0. Let's say this is an general equation which has been given to us. Now it is our duty to find out what conic it is. Conic, what type of conic this is. So let us try to equate this in this format: ax square plus bxy plus cy square plus dx plus ey plus, this is f, equal to 0. So from here we know a is equal to 1, b is equal to 4, and c is equal to 1. I guess only these three are the values that we require to find out what type of conic is this. If we use the discriminant formula or the shortcut trick that I had taught you. Now again, you can definitely solve this by using the delta or the determinant formula as well. However, this is very easy and would help you solve questions more easily during the examinations. So let's find out b square minus 4ac. B square becomes 16 minus 4, a into c becomes 1, so this is 12. That means we have our discriminant which is greater than 0. And what had we learnt? If b is greater than 0 or b square minus 4ac is greater than 0, then what does this refer to? It becomes a hyperbola. Exactly what we had studied here. B square minus 4ac, if it is greater than 0, it is a hyperbola. And that is what we've got as our answer. So again, I don't think these are the type of questions that generally JEE asks. They ask more complicated and more concept depth questions from parabola, ellipse and hyperbola. This is just for you to understand what are the terminologies that are used in this chapter. So now let us start with major things. First, let's look at what the center of a conic is. Again, we know for circle, let's say this is our center of the conic. So for a parabola, this is how a parabola looks like. This is the center. We also call this as the vertex as well. And let's say if I was to draw an ellipse, I'll draw it once again so that it becomes neat and tidy. This is how an ellipse is drawn. This is our center, but this is our minor axis, this is our major axis. And for a hyperbola, we all know our center is here. And I'm sorry, I'll just change this a bit here. This is what we call as the vertex, and this is our center. So we know what the center of our conic looks like. Now there is again a formula or a way how we can calculate the center of conic as well. So let us look at that. Let's say this is again our general equation which has been provided to us, which we've converted in this format: ax square plus bxy plus cy square. We have to find out the partial differential here. I think this might be a very new term for you all. However, I'll just give you a brief what partial differential means. Let's say if I was to take up the differentiation of this entire equation. Now for partial differential, since I'm taking it in terms of x, apart from x, I consider all other variables and all other constants to be constant. So for this equation, you can see the partial differential here is 2ax for this term, and then bxy, we've taken this as by, cy square, since there is no x term, so we consider this to be a constant, and this becomes 0. Here there is an x term, so this would become d. This is again no x term, so this becomes 0, and this also becomes 0. Similarly, when we are taking partial differential for y, for this equation we would take every other variable and every other constant apart from y to be a constant, and then we would differentiate it. So this would become 0, this would become bx, this would become 2cy, this would become 0, e, and f is again 0. So that is how partial differentiation is done. So for again to find the center of conic, once we've written down the general equation of our conic section in this format, we find out the partial differentiation. And once we found out the partial differentiation, we have two equations. There is x, there is y. There are two variables, two equations, two variables. We can find out x and y, and that would be our center of conic. So let's take an example. I'll take the previous example that we had just done for hyperbola. Let's say this is our equation, and if I was to write this in form of ax square plus bxy plus cy square plus dx plus ey plus this is f is equal to 0. Now let's try to partially differentiate this entire equation. So first I'll find out d by dx of our equation. And then I'll take the partial differential in terms of y for the same equation. So the question, basically I'll just write down what the question was. It was to find out the center of conic. Plus y square so again let us try to partially differentiate this. X square, this would become 2x, 4xy. Now y is a constant here, 4 is a constant here, so this would become 4y. Y square, there is no x term here, so this becomes a constant, so this goes to 0. Minus 7 is a constant here, sorry, minus 7 is a constant here, so minus 7 comes as it is. There is no x term here, 0, so there is no x term here, 0. So we've got our first equation, we equate this to 0. And let's try to find out our second equation. We have to partially differentiate this in terms of y. This becomes 0. Here there are two constants, which is 4 and x, plus 2y plus 8 is equal to 0. Now this is a constant term, this would become 0. This is a constant. While differentiating in terms of y, this becomes 0 as well. This is our second equation. So we've got two equations. Now again, there are two equations, two variables. You can simply find out what our x comma y would be. That would be our center. So let's try to solve it. Let's multiply this equation by 2. We would get 4x plus 8y minus 14 is equals to 0. Now if I was to subtract these two equations, then what would I get? Let's say this is our equation 3 and this is our 2. So 3 minus 2 would give us 4x would be cancelled. We would get 6y equal to 22 and y would be equal to 11 by 3. So we found out what y is. Y is 11 by 3. So you can put the value in any one of the equations of y and find out what our x is going to be. I leave that to you to calculate the value of x and find out the center of this conic. Now let's look at what focus is. Focus is a fixed point in a conic section through which distance can be measured. Again, now the distance of any point on that conic up till focus, and there would be another term that we would study, which is directrix. The distance would always stay constant. So for example, I'll take, now again in a circle there is no focus, there is just a center. Let's say if I take a parabola here, this is our parabola, this is our center, this is our vertex, and here somewhere here lies the focus. Now let's say if I take any point P on this parabola. Now this is a type of axis of this parabola which we call as the directrix. And if I take a perpendicular drop here and I consider this point to be M. So for parabola, this distance PF, PM will always remain constant. So in case of parabola, PF is always equal to PM. So that is the case, and this remains always same. So focus is basically determines how your conic section looks like. So I'll take ellipse also for an example to show you. Let's say this is our ellipse and this is our directrix. For ellipse, of course, there are two directrices, and let's say this is our focus, and for ellipse there are two focuses. You need to remember this thing. For parabola there is one foci, for ellipse there are two foci, and for hyperbola also there will be 2 focuses. For circle, of course, it is 0. And let's take any point P here. And if I drop a perpendicular here, and this point I name it as M. So this distance, PF and PM, will always remain constant. And if I were to take it this side also, this would remain constant. Same thing goes for hyperbola as well. Now the directrix, as I mentioned earlier while teaching you focus, this is a fixed line which is used to again define the conic section, and it is used as a reference for measuring distances to points on the conic. This is our focus, vertex, center. This is our directrix. This is our axis. We call this as the axis. And if I take any point P, I drop a perpendicular which is M, so M lies on the directrix. Same thing we will be studying in ellipse and hyperbola as well. Just you need to remember one thing, is that in ellipse and hyperbola there will be 2 directrices and there will be 2 foci. Now if I were to look at eccentricity, eccentricity is nothing but the distance of PF and PM, the ratio of those 2 distances. So let's take again parabola for an instance. Let's say this is my parabola, this is my vertex, this is my center, this is my axis. Now why am I every time defining all these things with their names? So that it becomes very thorough to you and you remember what exactly the terminologies are, because this is going to be used a lot in the questions while solving conic section. They just give you the terminologies and you have to understand what exactly they are trying to tell you. This is our directrix. This is our, let's say this is an any point P, X, Y on the conic. So we can say PF and we drop a perpendicular here, we get PM. So PF, this ratio is termed as the eccentricity. It is the ratio of the distance between a point on the conic and the focus and from the point to the directrix. Now there are different conditions as to how you can justify what eccentricity is. So for example, for parabola, eccentricity is equal to 1. That is why PF would be equal to PM. For ellipse and hyperbola also, let's look at those conditions. So if E is equal to 1, the conic is called a parabola. E is less than 1. Now of course E cannot be negative, so it has to be greater than 0 and equal to 1. And if E cannot be equal to 0 as well, if E becomes equal to 0, that means it is a circle. So I hope you can understand that PF by PM is equal to 0. That means PF is equal to 0. That means the distance between any point on the conic up to the focus is 0. That means there is no focus at all. So that is why it is a circle. And we have studied that in a circle there are no directrices, no focuses. So if E is less than 1, it is called an ellipse. E greater than 1, it is called an hyperbola. And E is equal to 0, we call it a circle. And there is one more thing, number 5, that you need to remember. If E is equal to root 2, then the conic is rectangular hyperbola. Again, we will study this thing in very much detail while we study the chapter hyperbola. This is just an overview, and these are the things that you need to remember, because sometimes there might be chances, 1% chances at least, that JEE might ask an easy question from these terminologies as well. Apart from that, you have to remember all these things, you have to remember these conditions, because there are at least 2 to 3 questions that come from this chapter. And it is necessary for you to understand what exactly the terminologies are, and so that you can solve the questions. So just a revision before we sign off the introduction of conic section. Let's say this is our axis. Then we know this would be our directrix. Again, this is not the y-axis or x-axis we are talking about. These two are completely different things. So there can be, let's say, this is our y-axis, this is our x-axis. There can be a conic which is in this format, let's say. So there would be a directrix here, there would be an axis here. So again, this is not x and y axis we are talking about. This would be our directrix. Our parabola would look somewhat like this. This is our vertex. Somewhere here there would be our focus. And since this is a parabola, E would be equal to 1. That means any point on the parabola, PF and PM, are always equal. Now, a few more things. There can be different chords of this parabola as well. Anything that passes inside of this parabola, which touches the parabola at 2 points, we call this as a chord. Now again, this chord can be perpendicular as well. Let's say if it is, I'll draw a new shape to make it more clear. Let's say this is our parabola, and this again is our chord, since it is cutting the parabola at 2 points. And if it is perpendicular to the axis, then we call this as a double ordinate. And let's say, since here was our focus, and let's say if this is our directrix axis, our parabola, here is our focus, and if this double ordinate passes through the focus as well. Now first of all, this is a chord, this is a double ordinate as well, and it is passing through the focus as well. So we call this as the latus rectum. Now this is a very important term, latus rectum. You need to understand what this is, because in future when we study parabola, ellipse and hyperbola, there will be a lot of questions based on latus rectum. So again, this is a chord. What is a chord? Chord cuts the conic section at 2 points. So this is a chord which is perpendicular to the axis, which makes it a double ordinate, and this is a double ordinate which passes through the focus as well. And if it is, so basically a latus rectum is a combination of double ordinate as well as a chord, and it passes through the focus as well. So these are the terms that you need to remember. So that was all for the introduction of conic sections. Now we will be starting with the first conic section, which is parabola, in the next lecture.